pleasant day greetings to you all. In this module, we are going to deal with basic thermodynamic processes, namely isothermal and adiabatic process. Understanding these thermodynamic processes is essential before we start to consider Carnot cycle and heat engine, which have many practical applications. As an example, let us take a refrigerator which works on reversed Carnot cycle and isothermal process. Carnot cycle and heat engine have many industrial applications too. Before we grasp what are isothermal and adiabatic process, let us first recall what is heat and what is thermodynamics. What is heat? Heat, it is one of various forms of energies such as sound energy, light energy, mechanical energy. And heat, it is created by movement of molecules or atom. By this statement, heat is created by movement of molecules or atom. We can say that a substance of molecules or atom with slow movement will be at lower temperature, and a substance of molecules or atom with vigorous movement will be at higher temperature. And it follows from the above statement that heat will be existing at all temperatures except absolute zero. That is, at absolute zero, the molecules or atom will have no movement. Then what is thermodynamics? Thermodynamics, it is the science of energy and entropy. It deals with the relationship between heat, work and energy. It concerns only with large scale observations, that it does not bother about the microscale observations. So what is isothermal process? When a change in the pressure and the volume of a given mass of substance takes place at constant temperature, then the process is said to be an isothermal process. As an example, consider a gas contained in a cylinder and it is being compressed by a piston. Let us assume the piston is moved very slowly so that no heat is evolved during the movement. Also, the walls of the piston and vessel are good conductors. So, if at all any heat is evolved during the movement, as the walls of the piston and vessel are good conductors, the evolved heat will be conducted away by the cylinder to the surrounding air, that is the environment, and the temperature of the substance remains constant. This animation will help you to understand isothermal process easily. Here we can see that as the piston goes down, the volume decreases, the pressure increases, and the temperature remains constant. The gas equation for isothermal process is PV equals R into T. What is adiabatic process? An adiabatic process is a process in which changes in volume and pressure of a substance takes place in complete thermal isolation. That is, during an adiabatic process, no heat is allowed to enter or leave the system. Hence, the temperature changes. Again, take example. Consider a gas enclosed in a cylinder fitted with a piston. Assume that the cylinder and piston are perfect insulators of heat. That is, during the movement of piston, that is, when the gas is compressed suddenly, heat will be evolved, and the heat evolved will have no way to leave the system, so that the temperature increases, and if the piston is expanded, that is, when heat is reduced, the temperature decreases. This animation will help you understand adiabatic process. Here you can see that as the piston goes upwards, the volume increases, the pressure decreases, and the temperature falls down. In the next module, we will deal with the gas equations of isothermal and adiabatic processes in detail. Thank you.